afternoon, dear professor and participant. My name is Halil Potter. I am glad to participate in this climate resilient agriculture for ICA 18 TSAE International Conference. I am going to talk about effect of internal fans and the melting behavior and energy storage in latent heat systems. Abstract. This study presents a comparative numerical analysis of two latent heat thermal energy storage systems, a basic cylindrical configuration and enhanced model for treating internal fans. Both systems utilize phase change materials as the storage medium and are equipped with U-shaped internal heat transfer tubes for the circulation of heat transfer fluid. The thermal charging process was simulated using console metaphysics by solving the coupled Navier-Stokes and heat transfer equations under transient confidence. Natural convection at the outer surface was also considered to account for ambient heat exchange. The simulations investigate the temperature evolution, fluid flow dynamics, melting behavior, phase transition characteristics, and thermal energy storage capacity of both configurations. Results indicate that the presence of internal fans significantly improves heat transfers within the PCM domain, leading to faster melting rates and enhanced thermal storage performance. The finite LHTS demonstrated a more uniform temperature distribution and higher melting fraction over time, confirming the effectiveness of conductive enzyme structures. These findings provide valuable insights for the optimization of PCM-based thermal storage systems, particularly for applications requiring rapid energy charging and efficient heat management. Introduction part. This figure compares the configurations of a PCM block with and without internal fans. The presence of fans enhances heat transfer and accelerates the melting process, whereas in the absence of fans, heat preparation occurs more slowly. There are, in terms of scientific publications, countries such as India, Iran, China, and several others are taking the lead. Within the scopes of this study, the articles were searched in the Scopes database. The highest number of publications were recorded in the years 2023 and 2019. Next, percentage of materials and methods. In this study, finite elements analysis was employed to numerically simulate the thermal and fluid behavior of two latent heat thermal energy storage configurations, simple and defined using console multipliers. The FEE-A method enabled accurate modeling of the coupled heat transfer, phase change, and fluid flow processes within the computational domain. by discretizing the geometry into a high quality mesh and solving the governing equations for moment, energy and phase transformation using FMA. We were able to capture detailed temperature distributions, melting fractions, and velocity field over time. The simulation results provide insight into the performance enhancements achieved through the fine geometry compared to continual setup. Simulation results. The PCM selected in this study has a melting temperature near 85 grados and initial temperature of 20 grados. The thermophysical properties of the PCM were taken from material database and literature. The most materials: water, PCM, aluminum. Figure 4 displays the surface temperature contours of two latent heat thermal energy storage units at 5 distinct time intervals: 1 hour, 3 hour, 6 hour, and 9 hour, 12 hour. Figure 2a represents the sample configuration, while panel figure 4b corresponds to the final configuration. In the sample configuration, the temperature distribution reveals a gradual thermal penetration into the PCM. The core region remains significantly cooler even after 12 hours, indicating slower melting and limited heat conduction when the prepared at 1 hour. Only the outermost layers experience noted double temperature rise, while the core remains near its initial state even at 12 hours. Large unmelted zones remains evident from the persistent dark blue areas representing temperature below 330 Kelvin. Next percentage of result and discussions. In the sample configuration, the temperature evolution at all three positions shows a gradual and nearly uniform rise, with all points converging to approximately 332 Kelvin by the end of the charging period. This behavior indicates limited internal thermal conductivity, resulting in slow and homogeneous heat propagation within the storage domain. Conclusion: in this study, a numerical investigation was conducted to evaluate and compare the thermal performance of two latent heat thermal energy storage configurations, a simple configuration and fine configuration. The simulations were performed using COMSOL multiphase, incorporating finite element analysis under transient conductions over a 12-hour charging period. Natural convection was considered across the surface of the storage unit, and water was used as the heat transfer fluid. The results demonstrated that the finite configuration significantly improved thermal performance compared to the sample design. Temperature distributions analysis revealed more effective heat penetrations and higher thermal gradients in the final LHTs, particularly in the bottom and middle regions. The melting frictions and stored energy analysis further confirmed that the addition of fines enhanced the rate of phase transitions and increased the overall energy storage capacity in the critical regions of the piscine domain. Reference. Thanks for your attentions.
बोल दीजिए, ये और किसी